what's going on? I mean, if you do it now, because when I put epoxy, I'd rather wait and sit, so.
That's it. It's just, all right, you hold on to that section, I'll hold on to this section. No, don't pull. Just keep.
It's the six on there.
Yeah, it's like you guys want to put them together really quick? I'll take this, pull this apart.
That's what we're about to attention to.
Wait a minute. Don't twist too much code if you got stuff in there.
We're back
You guys want to hit it? You know how to do that.
Not being powerful. That's not it, no. Look at it, it moves. Alright, let's see.
Battery's dead.
No, the batteries are fresh charged, they're full.
Are those, are 1866 living?
On. Off.
Start on. This needs to go back up. Huh? The arm needs to go back up. Or no, I don't know what I'm thinking. Oh. Sorry.
What is it with me? You don't.
Start on.
Alright, here we go. We need to pull it.
Fine. Okay, fine. Hold on. Nobody cusses on the video.
Close the door.
Okay. Kill it.
Yeah. Close the door. The switch is still. Using 30. Celebration, did it stop on its own?
Light. Oh wait, there. Okay.
Go. No. No, let's let go. Into the rocket.
See, I got a problem with
So you guys
That's the actual size of your yes, this is we built this to spec as mentioned on the sites. And it's and all of our tested is working very At 1,000, the payload is jettisoned, pulling out its own payload chute, and of course a main. The payload, the drill core, runs up past the main, so when it throws the payload chute and the main out. So there's never really a lot of worry about if one's going to stay on tube.
You go ahead and pull these down, right? Did he tell you what I said earlier? Tell me if I
This is done 7 months.
Yeah, well.
I have a suggestion on all this stuff. You may want to zigzag fold it and then rubber band or tape it to keep it as a hardly alignment. Sometimes if you push up just a block, you get loop the tortoise. It's not very
So are you twisting wire?
Alternators and the other ones is where they all run on an independent.
The battery is connected.
It is after the batteries installed. Yeah, we just take this in today.
As long as it's in there.
I mean, we counted ours. It took about 2 minutes to do it all. 2 minutes for all out of
And so one of the things that we're working on here is additive manufacturing or 3D printing and whether or not it's applicable parts from powder effectively. So one of the challenges we have in rockets, one of the challenges is that the parts are really expensive and a lot of times they take a long time to build. So additive manufacturing or 3D printing allows us to build the parts quickly and for big vacuum
laboratory. So what we've been doing here since about mid-1980s is first off developing life support systems for the International Space Station. We're also involved in supporting flight operations for the space station. So if we get any problems or anything like that, we have ground functional simulating equipment that we can run through the paces and try to figure out what's going on and why. We've also got an installation unit. So from lays down a very thin film filled with urine inside this vacuum distiller. In the vacuum, causes the water to evaporate, so it's pulled hard vacuum, the water evaporates without really having to do a lot of heating. And it's compressed on the other side and then condenses. And so we've got a little bit of a gradient across that with a latent heat type gradient.
They have a plant called Michoud Assembly Facility down in New Orleans, Louisiana, where they built the Saturn rocket, where they built the external tank for the space shuttle, and where we plan to build the SLS rockets that we're working on the design and manufacturing processes for right now. As I mentioned from the name of the facility, we're primarily interested in welding processes used to manufacture rockets. A lot of people, when they think of welding, think of what we call fusion welding, when we take the two parts, put them together, use the heat source to melt the edges together and let them solidify. We do fusion welding development, but we don't do a lot of it. A lot of what we do now, or most of what we do now, is what's called friction stir welding. It was a process invented in the 1990s at the Welding Institute in England.
All right, all good? Next. Okay, it's all marked now.
Yep.
All right, what's next?
Mark. Place the arm in the default position. Need to check default position again in a second.
You're gonna need a flathead screwdriver.
Okay, Grant.
No, Jordan has it.
Pick it up. Plug in power supply to arm. And you said power supply and data are all the same thing?
Huh? Yeah, it's all in one. Power. Data.
Hey, can somebody have like a rag or a...
All good. Matt, you want me to check it now? Can we check now?
That's like at the end.
Now we open the payload door to specified height.
Look how many holes I created.
So let it go until it naturally stops on its own. Or that. All right.
And it's going
We're good, Mark? It's pretty much where it
that's it.
you don't push down ever. You let it stop on its own.
Okay.
I'm trusting your judgment.
Mark, place the payload in a specified area. We're gonna run through this a time or two. So. Alright. Edwards, make sure the spring pin is in open position. Alright, good. Edwards, check the winch switch. That's in correct position. Grant, check all connections. So you're not checking power yet. You're just checking the connections.
Our connections are good.
Okay. So now activate the pause switch. Activate start switch.
It's on.
All right. Check arm power. Red light on bench. Grant, verbal confirm.
Confirmation of power is good.
And release pause switch to begin sequence.
Begin. Tell me if I need to pause, guys.
You were making the grass for that.
You guys don't pause?
Yes, the whole time.
And unpause?
Be careful.
This feels about to be like that.
Don't worry.
You just push that door down. Yeah, it did. No, it's good.
Pause. Unpause.
Looks good.
And pause?
Unpause. Let it run.
Pause. Activate.
It's a cool noise.
All systems go.
Light good?
Good. Why is it?
No, look. They see every step I do.
Oh yeah, go for it. It's Cody wanted my spot. So
I understand why we have to.
Maximum. Okay. Reset it.
turn on the pause switch, turn on the start switch. We always check this power. This is the main power of the arm. This red light indicates that it is armed. We're going to go ahead and at your signal, turn off the pause switch.
Now you see the arm goes to the default position. You can stop it at any time as per the handle. Go ahead and stop it, Grant. Locks right in place. There's no play. And if you go ahead and resume, please. Now those neodymium magnets are very, very strong for their size, so we're not worried about it busting up.
Go ahead and pause it. Show you pause.
At any point, if we have a safety issue or anything like that, somebody else needs to do something. Somebody forgot their phone in front of the rocket, no problem.
And go ahead and unpause it. You'll see as it gets closer, the controls are starting to level. You'll see it lock into place. Permanently locking it using a cover.
And also the kill switch kills if we have a redundant system. Same thing.
The igniter to go. Left it in. Go ahead and pause it. Unpause.
And there you have it. It's now ready for launch.
I'll activate the pause switch.
All systems go.
All systems go.
Right,
85 C and 85 2 and 85 2. 85.1 is an average.
85.15 is an average.
0.13.
yeah, just so we can.
Point one.
Yeah.
0.1 negative and it read.
Okay, just to check the line. I was looking at here.
See the pause light here, the yellow light is fully lit. I'm going to go ahead and deactivate the pause switch now.
Okay, go ahead and just kill it and give her the all
I'm going to give it a
systems go.
pause real quick. Alright. And we're going to go ahead and give you the all systems go.
All this is that we designed within a CAD program.
It take about an hour a piece.
Jordan
to
over
do,
there, he's our
it's
CAD
been
guy.
very
He's
easy
a
to
miracle
prototype
worker
this
with it,
because of that.
and these magnets fit right in there, and it allows us to cut because you can't buy these. That's something that we dreamed up, and the magnets, work very well. And it's kind of like I said earlier on the redundancy system. These magnets, if we get it close enough, we're going to shut it. But that arm also pushes it all the way there. The same thing with the only thing that I think doesn't have a redundant system, which you even could say, is the igniter.
Do you have the other pedal? It's not the right.
This is my first attempt.
That was my bad. I hit the wrong button.
Oh, did you really? Okay. Got the jitters.
Right, here we go.
You want to pause it? Rare magnets.
Okay. And 3, 2, 1, go.
Cut the power. Did you hit that?
Do that again. My bad.
I did the the wrong switch.
Ready?
Hold on. You gotta say ignition. Okay. That's what happened.
All right.
minute? 103.
103.
That's it. All right.
I don't think they're using their arm. Yeah, their legs are moving. They didn't run their arm, did they? No. They didn't load the payload? Did they? They all look fence. Huh? So they all look fence, did it? I didn't get a good look at it. I think it's really bent. Like I saw for like a bow. Have they measured their degree anyway? No. They're going to do that. Right. Well, I saw y'all here last night. That's awesome.
We were just fine tuning some things last night.
Well, we were too, so no shame in that. It's like you got to get it right.
We don't want to tie this yet. We just want to show them to go to the vertical and do the niter first, because they still have to charge the pen. They're not even ready to do the full system.
Well, I thought we would have to actually do it.
Just do the other way around. Whatever they say, that's alright. I think kind of that. I'm seeing that we don't know this already. So whatever we go do that, like this one still, like saying we want this and this rather than that.
I'm going to start wandering.
On the base, we have, you can see from this angle right there, there's an NVIDIA Jetson board that processes all that computer information that talks to the people in the black we have on top, which then controls the motion of the actual system. And so then you can see the sample is down there. It has a specific protocol. It sends to the quick disconnect, open the payload bay. Then
Must be durable. They got standing on it.
Yeah, we can get into the space.
wasn't sure if they were going to want us to come out or not.
Can you give me some points? I'm asking 35. Your logo.
I will be down at the Embassy Suites, just hanging out in the lobby. I'm going to be there from about 5 o'clock till 7 o'clock. So if you want to come down and talk rockets, if you want to come down.
One of the centrifuges. Things around,
Let's get a picture of everyone. Can I ask you to take a picture of all of us?
Oh, go ahead.
All right, good.
All right, Mark, fix it.
Louis said they found one that measures 40.2 pounds. Is that good?
Yeah, that's good.
Great.
Our rocket weighs 40.2 pounds. I'm going to go lay down and measure.
Does it?
Grant, it weighs 40.2 pounds. Keep waiting.
I don't.
It's got to be a big
Why did we bring a pulley away?
I don't think that was Discovery.
Yeah, dude,
I said it was NASA TV because they said they're going live at 7:15. Discovery's not going live. NASA TV is setting up on that NASA trailer.
Yeah, that's probably right.
All right.
Just see rockets going up. Well, last year they were in Salt Lake City. Oh, were they? Yeah.
I didn't know about those two.
I think they rotated.
They've done their shit.
That's actually. Mark set the arm. About to own the yellow door. Not going to go that trash. So, alright. That should be perfect.
Taken care of.
Thank you.
Of course.
Let's see.
It pushed it too far.
I can tell you right now.
10 o'clock.
Is there last time? The danger zone. We're good. Getting low. Is that good? You sure?
Are we going to the limit of the sky? He said he's been wanting to do that all day.
together as like the two non-people to put together one rocket, so that's like a lot of moving parts. A main at 1,000 feet, and A&M is going in 5, 4, 3, 2, 1, go.
The wind
For 3,000 feet and a main at 1,000. Arkansas going in 5, 4, 3, 2, 1, go. That moved. We have, looks like a main at 1,000 feet. We are going in 5, 4, 3, 2, 1, go. I think the motor quit burning before I left the rail. Pad 50, we are going in 5, 4, 3, 2, 1, go.
It's a good plot.
Shot cord's yeah, can you Z-fold shot cord in? Yeah. Witnessing this is take the middle in fact happening. I did do this. You did the fold with the payload container shot cord. He's got it on video. Okay. I'll tell you. So if something goes wrong, it's always your fault, man. What's up? Check this one. Hold on. Absolutely. Right. Not good? Check this one. Alright. Let's turn it around.
Here's your team, so Tyson, if you're ready, let's go ahead and start down there on the business end by the engine. I'll let you go ahead and introduce your entire team.
Thank you, and here is the team of the University of North Dakota. We have Jacob, we have Harry, Jeff, Gregory, Rebecca, Nikolai, and Lucy. So my name is Sofian, and as you can see, we come with the frozen University of North Dakota. The rocket this year. Using the K-1275, it's a red flame motor, so it will be beautiful going out.
We certainly hope so. And tell us a little bit about the paint job here.
So the paint job was made by Zuchu here, and he like did it as a.
Is it going, man?
You can explain by yourself.
Take this.
Okay, so together we learned that if we work together, we can go more farther than if we work only like each one alone. For me personally, I'm happy about what we've done this year, and I can come back to my country with a good story to talk about.
Maybe putting rockets into space as well.
We're good. All right. Now we'll try to take this. I'm going to twist it. That holds it. Usually. No? All right, we didn't twist enough. Ready? Here we go.
You're connected to Third Rock. It's radio. Powered with that.
Comes to 3D printing, so as I look at this note card right here, the entire thing gets 3D printed. And we'll give all the shout outs to everybody who's helped these students come here and participate in the student launch event. So I'll let you guys kind of walk on and take care of business if you've not done your signing real quick. And one thing we always like to talk about when it comes to dealing with students,
temperature,
we want to plug what the agency does.
68. I also need our pressure.
That roll out for the fall semester, the spring semester.
It'll be around 30.
So the deadlines are coming up as you go on to
there's no way.
Chase down
Atmosphere doesn't do that.
University of Illinois, pad 64, flying the Albatross, going for 3,600 feet Looks like we have a sample deployed at 1,200, another event at 1,000, another event.
Oh, there it goes. It's just Trojanowski.
Nope, way over there.
It's like 100 feet off the bed.
Now back to the launch.
It looks like you really use it.
We need the rocket over there, guys.
That's right here.
Straight up. Give a young lady a second.
That's not us.
Oh, she's not you guys?
She's hanging. She's
Well,
been
someone
hanging out
from
with
your
us.
team needs to do that also.
If you're lucky.
You got Homer to sign your rocket.
Yeah.
Hang the fins out over the end if you want to.
That's good.
Yeah.
Hey, pick it up.
It hurts the fins. Not strong enough.
Yeah, that's true.
Yeah, when we have a 9-pound rocket and a 25-pound motor, that's don't let it hit the fins.
1,000 feet, we've got 6 pins, we've got a payload separation with a payload chute. Also, main parachute comes out behind that.
Okay. You guys are comfortable, you got everything all pinned in and tied together and all that kind of stuff? You got an E-match or an igniter or something for this? You got any special tools that it takes to turn stuff on and off?
Magnets.
Okay. You haven't demagnetized all your credit cards or driver license yet?
Yeah, I'm keeping them up front, pockets in the back.
Okay. Show me where your center pressure is marked on the rocket. Okay, balance the rocket up on this.
Bring back, give them both pockets. That's your flight. They're going to give you, bring it over to mark down. Bring your rocket back here. He can measure the altitude.
Okay. You still got, you got a good caliber, so you stay. Okay, take it off. Okay, so looks like you guys are ready to go. Here's the deal. The guys, see the big camera here? For any of the
Keep that nose up.
Wait, so is it angled 85 the other way?
No, it's angled this way.
Don't put your hands on the pin, keep it straight, just get concentrate on
Warning, don't let go of that rocket.
Okay, hold on to the rocket, guys. I'll get the rail.
We'll have to wait until we get a pad man.
Somewhere in the general neighborhood.
Sit there long enough, the altimeter's like, you want to go check them again? Oh, I'm probably going to go turn them off and turn them back on.
You guys need to know when you fly.
Yeah, that was payload main, right?
No, that was booster main.
It's gonna and payload at 1,000. And Tarleton is going in 5, 4, 3, 2, 1.
Right in the sun. Yeah.
Oh yeah. That was where.
It's straight up. It's straight up.
Look at the sun.
Yeah. Okay, you got your band.
Yeah.
No, that's payload.
I couldn't see anything below it. Is that planned or was that
Payload that pretty quick.
Nice. That payload's hanging out there for a while. The payload's going to be there till tomorrow morning. They might have caught an updraft.
And is it supposed to come out at the apogee of payload? That's gonna be a walk. Yeah, great flight. That's gonna be a walk though, I think. It's right there. It's still floating.
It's about to happen. It's like our foam inserts.
Yeah, those come out. We're not finding them.
If you start walking now, you catch up. The rods and the fluid, so that they may not like perfectly concealed it off the ground. We're really appreciative that you guys took the time to complete this challenge. You did a great job. You should all give yourselves a round of applause. Let's go ahead and hear from Orbital ATK. Let's bring Rory Russell up here from Orbital ATK here at the Marshall Space Flight Center.
Good afternoon. This is the 15th student launch that we've had, and this is the 8th year in a row that Orbital ATK has been the corporate sponsor. And we do this because of all you, and we actually want to say thank you to you for you coming out and taking the time over the last 8 months and putting all your time and effort into this. And to quote JFK a little bit, I want to say, you know, we do this because, not because this is easy, because this is hard, right? We do this not because it's something easy you can do, but because it's something you can show that you excel in. And we very much look forward to you guys in the future and your careers, and thank you for coming.
So here we go. The first award we have is the Autonomous Ground Support Equipment Award. This is a university-only award to design autonomous ground support equipment to capture a provided payload and contain it within a rocket.
And the award for this year goes to Vanderbilt University.
And now to the Cancer Award. The Centennial Challenge Award. Joining us for that is the manager of the Centennial Challenge at the Marshall Space Flight Center for NASA. This is Sam Ortega. Sam, why don't you go ahead and do that?
Thanks, Bill. So first off, I want to give a big thank you and have her come out and join Lee Smith. So Lee has been the project manager for this MAV challenge. She's the one who organized and interacting with this whole challenge. So quickly, taking on the cost of Lee. So as you all know, this has been a very difficult challenge. It's been 8 months in the working. We've all read the rules. What we're trying to do is advance these technologies for future space exploration. Be able to take some samples, put them in a rocket, and put them into orbit around the planetary surface. So you guys know how difficult it was. You've done your effort doing that. One of the rules was that the requirements to be able to do the most difficult part was the autonomous ground support equipment system. And being able to develop a system that run perfectly and flawlessly and did all aspects that was required to be able to win the prize money. So I'm very happy and very pleased to say we're going to be able to award 2 checks today. And so our second place winner for the MAV challenge is second place for $50,000 to Tarleton State University. Woo!
Yeah!
Of course, that's not for the overall, challenge, but it is a portion of the overall thing. It's actually where the money, the prize money, is able to be handed out. We actually won $15,000 today. You know what? We're gonna take it. We're all gonna advance ourselves in the rocket certification level, pretty much to make it where it's easier for us to launch big rockets. We're also gonna take it and get new tools and stuff to help future rocket teams out. You know, it's one heck of a ride, I'll say, but it definitely is fun. The NASA guys know how to put out a good challenge, and it's definitely brought us together as a team, and I'd say that definitely made it worth it. I definitely plan on being back next year, as many of the other members do. Not quite. I'd hope to go into the automotive industry somehow, in the engineering aspect. But after this 8 months of designing, building, and documenting a rocket, it's really influenced me to consider aerospace. they are hoping to inspire young minds to make a brighter future for the world. Oh, they definitely do. They definitely inspired me. Well, pretty much we're going to try to get more innovative, make it easier to transport. We're going to try to make it lighter.